Hello students, myself Jalpa Shah, Assistant Professor in Computer Engineering Department, Aditya Silvarok Institute of Technology, Silvarok University. Today we are going to see the topic of the subject, that is Analysis and Design of Algorithms. In short, it is known as ADA, which comes in the 5th semester of the curriculum of the university. So now let's see that today what we are going to see, that is the selection shot, its example, algorithm, its analysis, and the C program of that selection shot. So learning objectives of the selection shot is to interpret the code for the selection shot, trace code for selection shot algorithm with the input data, identify factors that could influence the efficiency of a selection shot implementation, to be able to explain and implement the selection shot. So these are the learning objectives of today's lecture. Now, first of all, let's understand that what is selection shot. So in selection shot, we have to scan the array to find its smallest element and swap it with the first element. Then start with the second element and repeat the process. Continuing in this fashion, we can sort the entire list. So the list gets sorted in n-1 passes. So this is the total overview of the selection shot. Now let us understand this concept by the example of array elements. So here we have taken total 7 elements, that are 70, 30, 20, 50, 60, 10, 40. So now we have to sort this element using the selection sort. So pass 1. So we have taken the original array, that is 70, 30, 20, 50, 60, 10, 40. Now here we have to take 3 pointers, that is I, min and j. Here first we will take I equal to 0, j equal to 1 and I is equals to min, and always we need to check the condition, that is if a of j is less than a of min, then we have to apply minimum equal to j. So let's see that first we have assigned I and min to 70 and j is to 30. So now our your minimum index, that is 0. Now we need to check that if 30 is less than 70, then minimum equal to j. So minimum will become 1. Now your j pointer will be incremented. So again it will be compared, that is if 20 is less than 30, then minimum equal to j. So again minimum will be assigned to pointer 2. Now again j will be increment. So now we need to check, that is 50 is less than 20. No, it's false. So your minimum will remain on 2. Now again j will increment. So if 60 is less than 20, again false. So still minimum will remain on pointer 2. Now if 10 is less than 20, then minimum equal to j, that we have to apply. So minimum will become 5. Now again it will check, that is 40 is less than 10, false. Minimum will be applied to 5 only. So now we can say that our minimum element is found on location 5, that is 10. So 10 and 70 will be swapped, that is swapped with a of I and a of min. So swap a of 0 and a of 5. And then again we need to increment the values of I, j and min. So here we can see that at the end of pass 1, 10 and 70 are the swapped. And at the end of pass 1, we can see that 10 is the minimum element of the array and it has occupied its position. Now, starting with pass 2. So now we have to assign I and min pointer to one index, that is 30 element, and j, that is greater than 1 of I and min. So that is assigned to index 2, which is the 20 element. So now again we need to repeat the same process. So if 20 is less than 30, then minimum equal to j. So minimum equal to 2. Now 50 is less than 20, condition will become false. So minimum will remain 2 only. Now again j will be incremented. So if 60 is less than 20, false. So minimum will be assigned to index 2. Again 70 is less than 20. Again, condition will become false. So minimum will remain on location 2 only. Again, it will check if 40 is less than 20. Again, false. So minimum will still remain on an index 2. So now here, after completing the whole array, we need to swap a of I and a of min. So swapping of a of 1 and a of t2, we can see that 20 has occupied its position, and now we need to increment the I, j and min pointer. So now I and min are assigned to index 2 and j is assigned to index 3, which is greater than 1 index of I and min. So if 50 is less than 30, false. So minimum will be assigned to index 2. Now, again, it will check the condition, that is 60 is less than 30, false. So minimum will be assigned to 2 only. 70 is less than 30, false. Again, minimum will remain on the same index, that is second index. Again, it will check and increment the pointer of j. So if 40 is less than 30, false. So minimum will remain on an index 2 only. Now, we need to see that swapping a of I and a of min. So swapping of a of 2 and a of 2. So that will be 30. So we can see that 30 has occupied its position, and we can see that we have to increment I, j and min pointer. Now, we have to go on a next pass, that is pass 4. So that is 10, 20, 30, 50, 60, 70, 40, which is the output of the pass 3. So that will be taken as an input into the pass 4. And now I, min and j will be incremented. So I and min will goes to the index 3 and j will goes to index 4. So if 60 is less than 50, false. So minimum will remain on an index 3 only. Again, it will check 70 is less than 50, false. So minimum will remain on an index 3 only. Now check that if 40 is less than 50, yes, condition becomes true. So minimum will be assigned to j. So minimum will be changed to index 6. Now we have reached to the end of the array. So now we have to swap a of I and a of min. So 50 and 40 will be swapped. So we can say that is a of 3 and a of 6 will be swapped. So 40 has occupied its position at the end of pass 4. Now again we need to increment the value of I, j and min. So now pass 5, that is 10, 20, 30, 40, 60, 70, 50, which is the output of pass 4, and that is going as an input to pass 5. So now I and min will be assigned to index 4 and 70, that is j, index assigned to 5. So now if 70 is less than 60, false. So minimum will remain on index 4 only. If 50 less than 60, then minimum equal to j. So minimum will be assigned to index 6. Now we have to change a of I and a of min. So we need to swap the elements of a of 4 and a of 6. So 50 and 60 will be swapped. So we can see that 50 has occupied its position. After this, we have to increment the value of I, j and min. Now, our output of pass 5 will be goes as input to pass 6, that is 10, 20, 30, 40, 50, 70, 60. So I and min will be assigned to index 5 and j will be 1 greater than, that is assigned to index 6. Now we need to check that if 60 is less than 70, then minimum equal to j. So minimum will be assigned to index 6. Now we have to swap a of I and a of min. So we have to swap a of 5 and a of 6. So 60 and 70 will be swapped. So you can see that at the end of pass 6, 60 has occupied its position. So by default, 70 is going to be the last element, which is already going to be on its position. So as we have seen in a starting that here your array will be sorted in n-1 passes. So total 7 elements are there and our array is sorted in pass 6. So that is 7 minus 1 equal to 6. So at last we can say that our whole array is sorted. So here through example in a detail we have seen that how selection sort is working. So now the same process that we need to understand with the help of an algorithm. So starting with the name of the algorithm, that is algorithm selection, the array elements, then the problem description, that is this algorithm is for sorting the elements using the selection sort. What is the input? That is an array of elements, that is a to 0 to n minus 1, that is to be sorted. Output, that is the sorted array a of 0 to n minus 1, that is the sorted array that we will get as output. Now starting with the first outer loop, that is for I equal to 0 to n minus 2, do. Here we have to assign I equal to minimum. Then we need to start with the inner for loop, that is j is equals to always 1 greater than I to n minus 1, do. Now we need to check the condition, that is if a of j is less than a of min, then minimum equal to j. After doing all whole array parsing, we need to swap a of I and a of min. So temporary equal to a of I equal to a of min equal to temporary. So our whole array will be sorted. So here you can see that that is your whole outer loop, whereas inner for loop will be known as the inner for loop, that is for the comparison. Now we need to see that how the analysis of or the complexity of the selection sort that we are getting, that is in this algorithm, basic operation is comparison. So we can obtain the sum as follows, that is outer for loop with variable I, inner for loop with variable j, and the basic operations under that inner loop. So we will get that is C of n is equals to sigma I equal to 0 to n minus 2, that is for outer loop of I. Sigma j is equals to I plus 1 to n minus 1, that is for the loop of j, and the basic operation always will be 1. So if we solve this, we will get that is sigma of I equal to 0 to n, 1 is equals to n minus 0 plus 1. Using this formula, we will get sigma j equal to I plus 1 to n minus 1, in inner part is 1, that is n minus 1 minus I plus 1 plus 1. So we will get that is equals to n minus 1 minus I. So we will get sigma I equal to 0 to n minus 2, n minus 1 minus I. Now let's solve this, or to simplify this, we will get sigma I equal to 0 to n minus 2, n minus 1 minus I. So if we explicitly do the operations on different parameters, so we will get sigma I equal to 0 to n minus 2, n minus 1 minus sigma I equal to 0 to n minus 2, I. So we are doing the limit on a I. So now we will get sigma I equal to 0 to n minus 1, n minus 2, inner part is n minus 1, that will remain as it is. Now if we simplify this by the operation, we will get that is sigma I equal to 1 to n, inner is I, that is a series, that is n into n plus 1 divided by 2. So if we put n minus 2 instead of n, we will get n minus 2, n minus 1 divided by 2. So here we are putting that in a value. Again need to simplify it. So we will get that is n minus 2 minus sigma I equal to 0 to n minus 2, inner bracket 1. So just a minute. Yes. So now here you can see that is if we simplify again this by this formula, we will get sigma I equal to 0 to n minus 2, inner part is 1, is equals to n minus 2 minus 0 plus 1, that is equals to n minus 1. So again n minus 1 is common. Here this answer is n minus 1, and n minus 2 minus n minus 1 divided by 2. We will get n minus 1 common, so that is 2n minus 2 minus n plus 2 divided by 2. We will get n into n minus 1 divided by 2. So if we again remove the brackets, we will get n square by 2 minus n by 2. And as we know that whenever we are finding out the complexity, we need to consider the highest polynomial degree of n. So here we are getting 2 as the highest polynomial degree of n. So that is equals to T of n is equals to theta of n square, which is the time complexity of the selection short. So now we need to see the program of the selection short. So now let's see the program of the selection short. So the same thing that we have done with the help of the uh, algorithm, we need to do with the help of the program. So now let's start the Turbo C and let's open the program. So how you will write that? We first need to include the header files. So that is has include stdio.h, has include conio.h. Then we need to start with the main function. So now, first of all, we need to declare the variables. So here we can see that integer j, temporary variable is required by us, number of elements, then the array that we require of size. For example, 10 we are taking. So this many variables we require. After that, CLR, SCR is a function used to clear the screen. Now we need to take the values from the user, that how many elements that we need to take to sort the array. So first of all, let's take that is printf, enter the number of elements. So now we need to take that elements. So using scanf function, so that is scanf %d, comma, %n. So number of elements will be taken from the user. Now, suppose if I have entered 5, so I need to take the array elements. So for that, I require a for loop. So for I equal to 0, I less than n, I plus plus, in which I need to take the elements. So scanf function is required. So scanf %d, comma, a of I. So now, after taking the array elements from the user, we need to do the sorting using selection sort. So first we need to implement the outer loop. So for I equal to 0, I less than or equal to n minus 2, or you can say that is I less than n minus 1, I plus plus. Here, first of all, we need to assign the value of I to minimum. So value minimum equal to I. Now, after doing this, we need to take a inner for loop for j. So that is equals to for j equal to I plus 1, j less than n, j plus plus. Now, in this, we need to compare that if a of j is less than a of min, then we can see here in the algorithm that what we have seen, that is if a of j is less than a of min, then we need to assign j to minimum. So here you can see that okay. So now we need to start again. So here let's first type the whole program, that is has include stdio.h, has include conio.h, void main. After that, first we need to declare the variable, that is integer I, j, min, temp, and a of 10. CLR, SCR. After this, we need to take the number of elements from the user. So enter the number of elements, scanf %d, comma, %, and then we need to take the array elements from the user. So for or we can print a message also, that is printf, enter elements Now we can use a for loop for taking variables. So that is I equal to 0, I less than n, I plus plus. In that, we need to take the variables. So scanf percentage v comma ampersand a of I. Now we need to start with the outer for loop, that is for I equal to 0, I less than n, I plus plus. Now in that, I have to first assign minimum equal to I, then inner for loop, that is for j equal to I plus 1, j less than n, j plus plus. In that, I have to assign if a of j is less than a of min, then minimum equal to j. Now, if this is not happen, then we need to swap a of I and a of min. So temporary equal to a of I, a of I equal to a of min, a of min equal to 10. So here you can say that your whole loop is over. Now you need to print the elements. So printf shorted array. For within using for loop, we can print the array. So I equal to 0, I less than n, I plus plus. In that printf percentage d slash n. So that will give you the next elements, comma a of I. Lastly, get ch, and your whole program is over. Now, first of all, let's save this program. So in the folder, we are saving this using selection dot c. Now let's compile this program. Compile, done. Run this program. So after running this programs, we can see that number of elements we need to enter. So here I am entering 5. So again, let's open this code. So here already we have saved this code. So let's open this. So file, then open, you will get start.c. So you will get all your programs. Here we have saved our program. So let's open this, run this code. So number of elements is 5. So enter the elements. For example, I am entering 4, 5, 2, 3, 1. So you can see that your array is sorted. So here is the code that we have run for the C program. So here today we have seen all the contents that we have defined. That is, we have seen the example, then we have seen the algorithm, then we have seen the analysis, and lastly we have seen the C program of this. So here we have completed our selection short. Thank you very much, everyone.